All right, so today we're going to be talking about trig identities. So first, make sure you remember the opposite adjacent hypotenuse stuff. So sine is opposite over hypotenuse. Remember cosine's adjacent over hypotenuse. Tangent's opposite over adjacent. And then cosecant is hypotenuse over opposite because it's a reciprocal of sine. These are reciprocals of each other. Cosine and secant are reciprocals, so it's hypotenuse over adjacent. And tangent and cotangent are reciprocals of each other, so that's why it's adjacent over opposite here. So we're just going to be simplifying some trig identities, and we're going to be using these fundamental trig identities right here to try to be doing them. So your idea is that we want to rewrite things in terms of sines and cosines, and then we're going to reduce and cancel when possible. So tangent, if you look up here, tangent is sine over cosine. And so that's going to be, tangent will be sine of x over cosine of x. Cosecant is a reciprocal of sine right here. So it's going to have 1 over sine. And then cosine is already in terms of itself. Since these are all fractions, I'm just going to go ahead and turn that into a fraction also. And then we start seeing what cancels. So you multiply straight across, and you get sine x, cosine x, over cosine x, sine x. Now, since it's all multiplication and division, we can say cancel, 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 cancel. So we end up with 1. So our answer here is 1. So sine is already in terms of sine and cosine. I'm going to use this x. Cosine is 2. So I'm just going to change this to sines and cosines. So this is sine x over cosine of x. Remember, this is 1. So since this is multiplication right here, it's not addition. Addition, you can't cancel. This is multiplication here. So we can just multiply straight across. We get sine of x plus cosine x, sine of x. That whole thing is over cosine of x. Now you can see the two of these are going to cancel for us because it's just one fraction. You can remember, don't cancel when it's a plus sign. So I get sine of x plus sine of x gives me 2 sine of my x's. So down here, I have sine of x is already in terms of it. Cosine of x is already in terms of it. Tangent is going to be sine over cosine. And now we never divide by a fraction. Instead, you need to flip and multiply it. So I'm going to flip this fraction up. So I still have my sine of x times cosine of x. Now it's times my cosine on top, and the sine will go on bottom. So you just flip this fraction here. So now when you go straight across, you have a sine x times cosine squared of x over a sine of x. Now it's all multiplication and division, so those cancel. So your final answer is cosine squared of x. So over here, turn everything in sines, the sines and cosines. So this would be a 1 over cosine of x divided by a cosine of x times. This is a cotangent is cosine over sine. And you can see right here, if you forget, cotangent is cosine over sine. Over, and this is going to be, that's just the top, and the bottom is sine of x, cosine of x. So I'm going to multiply the top as one fraction of the bottom. So this becomes, multiply your top, so I get cosine of x over cosine of x, sine of x. Now all of that is over, and now I'm just going to do the bottom part, multiply straight across. Cosine of x, sine of x, over cosine of x. Now this is just one fraction here, so these two can cancel for me, and I'm left with 1 over sine x on top. And do on bottom, again, the cosines cancel, I'm left with just a sine x. So now I'm going to flip and multiply that. So, because it's kind of hard to see, so I'm going to have 1 over sine x, and this is divided by, so it'll be 1 over sine x also. So that ends up giving me 1 over sine squared of x. And sine's reciprocal is cosecant, so I can flip this up right here and make it a cosecant squared. So this is going to be cosecant squared of x. All right, so now on to the back. You can have the Pythagorean identity. Remember, Pythagorean theorem is a squared plus b squared equals c squared. So these come from Pythagorean's identity. So you can have sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant, and 1 plus cotangent squared equals cosecant squared. Now you can also rewrite these, and they're all still true. Meaning, I could subtract over my cosine squared right here, and it would read 1 minus cosine squared, and sine squared would be left. So this is equivalent, so you're going to want to write that down. Same thing here. I could subtract over my sine squared. So I'd be left with cosine squared over there, and this would say 1 minus sine squared. You can do that for all of these. So you're going to want to write these down. So I could subtract over my 1, or I could subtract over my tangent squared. I could subtract over my 1, or subtract over my cotangent squared. So those are all equivalent. These are equivalent, these are equivalent, and these are equivalent on the paper. So what we're going to do is we're going to be looking for any of these Pythagorean identities. That's the first step. And then we're going to change everything to sines and cosines like we did on the front. So cosine squared plus sine squared, that's this theorem right here. That equals 1 for us. So that means we're allowed to replace the whole top with a 1. So I have 1 over, and then 1 plus tangent squared. Well, 1 plus tangent squared was my secant squared, so I can put secant squared. And then the last thing I'm going to do is add the secant squared's reciprocal. Let me find my other paper. Remember the reciprocal of secant was cosine. So that's what we're going to use right there. So we're going to flip this back to the top, and it's going to be cosine squared of x. All right, our next one here. So what I'm going to do here is I'm going to factor out my secant x because there's 2 of them here. So like pull out your secant x out in front. So if I divide that by a secant x, I'm done with tangent squared. And this, if I divide by a secant, that leaves me with a 1. So I have secant squared of x plus 1. Well, secant squared of x plus 1 is one of my rules right here. So I'm going to have a secant x times a secant squared. Secant times secant squared gives me secant cubed. Okay. Right here, cotangent squared x plus 1. That's one of the rules right here. So it's going to be cosecant squared. So I have sine squared x times cosecant squared of x. Remember, cosecant is reciprocal of sine. So I'm going to put sine squared x times 1 over sine squared x. So that gives me a sine squared x over a sine squared x. They both cancel, so it leaves me with 1. All right, last thing here. So 1 minus cosine squared. So remember, if we go to this right here, 1 minus cosine squared is sine squared. So we're going to use that property right here. So I have sine of theta. I'm putting x's here because I hate the theta sign. And this is going to be sine squared. So now remember, sine squared means sine times sine. So really, you could have rewritten this as a sine times a sine. It's all multiplication and division, so these will cancel. So I'm left with the cosine x over sine x. And cosine over sine, if you remember on the front, is cotangent. So your answer for that one is cotangent of x.